Okay, you're welcome back once again. My name is Victor Odigoma Oya. In this level where we are right away, we have done up to seven classes in indices. We've been able to look at the laws of indices and connected them to solving indical equations. Okay, there are a lot of problems we've been able to discuss inside those classes. I will implore you to check out on those classes you've had already so that you can be able to follow us. Where we're heading to right now is we want to connect indices to the theory of logarithm. Okay, we want to connect indices to the theory of logarithm. I will try as much as possible to make everything I'm going to show you here to be very realistic, tangible enough for you to accept that there's no manipulation in what we are discussing. Okay, now when we were looking at the laws of indices in the previous classes, we were talking about we were talking about something like this that says when you have a raised to power x times a raised to power y, okay, that you are going to add the powers. That's what we were considering in product law in indices. You are going to add their power, that it is the same thing as a raised to power x plus y. That's what we said. Okay. Now, how does this relate to logarithm, the theory of logarithm? Now, you will now have that log, if you now have log x in base a being added to log y in base a, they have to be in the same base. That what you are going to do is this will become log in base a, then bracket x times y. I'm sure that is clear. That's what you are going to obtain. So when you are having the logarithm of a number added to the logarithm of another number, it is equal to the product of it is equal to the logarithm of the product of the numbers. Do we get that? So that is that. Let me advance more. Then I will bring in some, something figures to buttress what I'm saying. B, that in indices, if you have a raised to power x divided by a raised to power y, that we subtract their powers and have a raised to power x minus y. Then in logarithm now says if you have log x in base a minus log y in base a, that what you do is you divide the logarithm of the numbers. That is, you take the logarithm of the quotient. You take the logarithm of their quotient. What I mean by that is that you now say log in base a, then you now have x over y. That this is how you are going to handle it. Just pause a moment. Let's advance a little bit further. See that in indices, if you have a raised to power x and this is raised to power and y, it has another index, then that this is equals to the product of their powers. That's what we said in indices. Of course, if you check the class we did that has to do with the summary of the laws of indices, you see us talking about this with a practical illustration. So this is going to give a raised to power x y, that is x times y. That's what indices say. But here in logarithm, it now says that if you have log x in base a and this x is raised to power y, that what you are going to do is take the product of the power. It will become the product of the power and the logarithm of the number. So this will become y log x in base a. That this is what you are going to obtain. Now, at this moment when I have taken this 1, 2, 3, now I'm going to bring in an illustration to buttress what I'm saying, because that illustration is going to capture almost about 2 or 3 of them, obviously. Now, I have in this illustration example, I have log 4 in base 10 being added to log 25 in base 10. Now, if you look here, you are going to see that what we are going to do is to multiply these two, values. So I am going to quickly say that this will be log, then in base 10, I would have 4 multiplying 25. Now, what is that going to give us? That is going to give us log in base 10, then 100. 4 times 25 is 100. Do you know we can rewrite this 100 as log 10 squared in base 10? Now, do you see that this will come in? This rule will come in, and we are going to have 2 log 10 base 10. Oh, had even I was able to capture one more rule. Okay, I will use it and enter that rule. Yeah, that this is going to become 2 times 1, which is equals to 2. But you are able to see the multiplication of this that gave us this. And then you are able to see that this that is raised to this power became the product of the number and the logarithm of that. The product of the power and the logarithm of the number. I'm sure you were able to see that. Now, can we use here now and enter somewhere and enter somewhere and enter somewhere? Recall in indices that we say that a raised to power 0 is equals to 1. Is equals to 1. Now, how logarithm handle this matter comes into this is that if you have log a base a, that it is equals to 1. The logarithm of a number to its own base is equals to 1. Now, you remember that what gave us here in indices is something like, let me have 8 divided by 8, which you know is 1. 8 divided by 8 is 1. And you know that this division here, I can rewrite it. I explained that in the way I was doing buttressing the laws of indices. I said that this 8 is 2 raised to power 3 divided by 2 raised to power 3. And then when you subtract these powers, you have 2 raised to power 3 minus 3. And that will give you 2 raised to power 0. You see that this raised to power 0 is the same thing as 8 over 8. It's coming from 8 over 8, and which is 1. It then means 2 raised to power 0, which is similar to a raised to power 0, is 1. So let's come out of here now. And log is now saying logarithm of a base a is 1. Let's connect. Let's connect. If I have log a in base log 8 in base 8, and I am looking for an answer for it, can I say let that answer be a? And then what I will do is to interchange this and now say let the answer be a. I will now say 8 raised to power a is equals to 8. That is when you interchange this number and the result. When you interchange it, okay, you will realize that here this thing can be changed in its index form, which is 2 raised to power 3. And that 3 will multiply this. I just trust God I'm not dragging you to, But the explanation here was very, very okay. The explanation here was very, very okay. Okay. And you saw me proceeding from this. You accepted that 8 over 8 is 1. And the same 8 over 8 took us to 2 raised power 0. And you know that we were saying that this is this. And in the process, we were able to arrive at this, which is similar to this. So if this is this and this is this, it then means that, that 2, a raised power 0 is 1. And 2 raised power 0 is also 1. Now we are trying to connect this. The word logarithm is saying that logarithm of a number to its base is 1. And then I came down here. So let me show you that this is also going to give us 1. So 2 raised to power 3a equals to 2 raised to power 3. This one is this one is this. Now, since the bases are equal, we can equate the powers and we have 3a equals to 3. If you divide both sides by what now? 3. You have a equals to 1. You see that here now, a is what? Log 8 in base 8 is equals to 1 because a is 1. So, that explanation is very, very, comfortable for this. This is okay for this to buttress that. Okay. Is there another thing any other procedure I can follow to still show this? Maybe in the course of time. In the course of time. Yes, I have seen something now. Which I can also follow. Have I told you that? Okay. That is still exactly what you're still trying to buttress. Otherwise, I would have applied it here right now and also show you. Okay, let's move on. Now, this is the application of is there any other example I can still use to buttress what I am saying here? Otherwise, I will go ahead in okay, how many laws have I taken? 1, 2, 3, and then this fourth one. Okay, this fourth one. Okay, so we have taken the 4 of them, and then we can now be able to apply them in solving problems. Let me take one problem before I conclude this class. Okay, if you are given to evaluate, please, I will not go beyond this. Just exercise patience there. So I have log, and then after this now, I will now enter the class where I will solve examples. Please check also the next class we're going to have. I have log 6 base 10 plus log 45 in base 10, right? Yeah, minus log 27 in base 10. Given to evaluate that, you see addition here and you see subtraction here, all are in that explanation. So you realize that I am going to have, since they are all in base 10, I'm going to have log. Of course, they have to be in the same base for this to be possible, or otherwise you can follow that way to handle it. Okay, so for this now, I'm going to have log in base 10. Okay, then 6 times 45 according to what we explained there, then divided by 27. So this is what we are going to have. For addition, you multiply, and for division, for subtraction, you divide. All right, so what is 6 times this? I can start breaking it down. I have log in bracket. You can see that 3 here give 2, 3 here will give 9. 9 will cancel itself 1, cancel 45, and give us 5. So I have 3 times 5. Yeah, 3 times 5. Is that okay? I said 3 here, 2. No. This is 2 times 5 rather. Sorry for that. 2 times 5, not 3 times 5 over 1. Okay, because 3 cancel 6 and gave us 2. 3 cancel 27 and gave us 9. The 9 cancel is F1, cancel to 45 and give us 5. We have 2 times 5, which is this, and then over 1. So finally, I have log log 10 in base 10. Let me write it like this. Log 10 in base 10. Or this is over 1. So obviously the answer is 1. We have shown it already there that logarithm of a number to its own base is 1. So this is our connection between trying to connect, the laws of indices and the laws we use in the theory of logarithm. So we are now going to enter into, please, you just have to be there. You can't afford to miss the next class. So please like our video, share it to your friends, who will need this detailed explanation, please. And then click on the subscription button if you have not done that. Promote us and be of an encouragement as we are making our impact. I trust God you like us to grow. And as you do that, God will bless you. Thank you so much.